On to the word problems. Yay, everybody's favorite. You should have already read these and tried them, so I'm going to skip to kind of our Buck's problem solving method where we want to box out what they're asking us to find. All right, it says determine how many drawings she needs to sell. All right, so we're going to define our variable, number of drawings she needs to sell. All right, and what variable are we going to give that? Let's go with D for drawings. All right. Well, let's read through and underline our important information. Brielle she needs at least 240. She already has the 180. And then she saves $5 from each drawing she sells. Well, okay, so now let's circle some of the mathematical words that we find in here, or phrases. At least is one. Each is a good one. That often means like we have a rate, so that's going to be our multiplication or division, depending on the problem. And let's get started. So at least means greater than or equal to. And then we have at least 240. And what does she already have that has to be at least 240? Well, she has $180, and then we're going to add to it $5 for every drawing. All right, so when we solve this, what are we going to find out? We're going to find out the number of drawings she needs to sell. Okay, so simply solve by using inverse operations here. We got 5D. Bring down that symbol since we're subtracting, right? We're subtracting from both sides. And then we get 60. And then we have one more step. Divide by 5, divide by 5. So D is greater than or equal to 12. All right. So it says, write and solve an inequality. Ooh, I didn't put interpret, but I want you to interpret. Okay, interpret that answer. Basically, what does this answer mean? We usually use the phrase up here, and then this part, right? What does this D right here represent? It's the number of drawings she needs to sell. So she needs to sell at least 12. What are they? Drawings? Yeah. Drawings. To be able to have enough money to get the fancy easel. All right. So there we go. There's our answer. And there's our answer. Hopefully you figured that one out. Let's move on to, let's see, who do we have here? Michael. I think I made a mistake here with, oh no, it's right on this page. All right. Well, we read it once and then we look and see what do we have to figure out and find. Okay, what's our target here? It says write and solve an inequality to determine how many go-kart tickets he can buy. So the number of go-kart tickets he can buy. And let's see, we'll call it T for tickets. All right, let's read through and underline important information. Michael saved up $73 to use at Funplex. Okay, so he already has that saved up. He only likes to ride the go-karts. Each go-kart ride costs $5.29, and I'm going to go back here to this phrase each. All right. He wants to have at least $10 left so he can try to get Mr. Woodward the cool stuffed animal and the claw machine. Wow. How kind is that, Michael? Appreciate you thinking of me. And so we underline the important information. Oh, I didn't underline at least 10. So that's what he wants to end with, $10, at least $10. Okay. So how I would set this up is I find that at least right there. I see the word each here. So I kind of know what's going to be multiplied. I know that 525 is going to be the multiplied value. Anyway, so at least 10, so that's going to be greater than or equal to 10. And then how are we going to get to 10? Well, Michael took $73 with him to Funplex, and then he's going to be spending $5.25 for every ticket. All right, that's one way to think about it. Okay, so you could do it like that. The other way you could think about it is think, well, if he wants 10, you could figure out how many tickets he could get, and when would that be, greater than or equal to the cost of the amount of money that he had, right? So, but that gets confusing because we don't know. In fact, I think I wrote it wrong. I think this has to be less than or equal to actually make it work. Okay, because, right, he doesn't want to go over the value of 10. But anyway, so this can get a little confusing because I like the way that it has at least here, and it sets it up nicely with the at least symbol in this at least 10. Okay, so let's try this one. All right, it's a little bit tricky because of this minus sign here. The 73 is a positive term, right? We look to the left of the term to determine how to cancel it out, and that's going to be minus 73 minus 73. So I have to bring down this negative sign, negative 5, oops, negative 5.25t is greater than or equal to, that's going to give us negative 63. And then if I divide by negative 525 and divide by negative 525, I get t over here. And then when I divide here, I get 12. And since I divided by a negative on both sides, okay, that shows me I have to flip that sign. All right, so then we have to say that t actually has to be less than or equal to instead of greater than or equal to. All right, and then interpret it. So he has to spend less than or equal to 12 tickets or buy. So the number of go-kart tickets he can buy. Michael can buy. Now here's the tricky part. This is why we need to star this one, star this part at the end. So this original inequality went with at least, but now we have a less than symbol. So we have to pick out a phrase, right, that goes with that. And instead of at least, since it reversed, we have to reverse the saying as well. So Michael can buy at most 12 tickets. It makes sense because if you buy more than 12 tickets, that's going to spend more money, therefore leaving less money to get Mr. Woodworth something cool from the claw machine. So there you go. That right there, changing it. We haven't had an example like that yet. So right where we changed it from at least to at most because we had to flip the inequality. Okay. So moving on, hopefully that's something that you'll take the time to go back and study, make sure you really understand it so you can apply it on our test. Make test days the best days by putting in the work. All right, now we have, what do we have? 4 other types. My guess is that we have 4 operations, so 1 for each operation. Let's see how it works. Okay, so we gotta write. Oh, this time I remember to put interpret the solution. I even capitalized it. Okay, write and solve an inequality to find out how long it will take Evan to finish the assignment. So, how long it will take, and what are we, let's see, what are we measuring it in minutes? So we could say how many minutes it will take Evan to finish. Okay, and let's make that, because it's time, we can do T, or how long we do L, but I'm going to do minutes because I read up here that it was going to be minutes. Okay, so let's go through and underline our information. Evan completes problems at a rate, 10 problems a minute. Rates usually, we usually end up with some multiplication or division there, so I'm guessing that's what we'll do for this one. He needs to answer at least 120 questions to complete the assignment. Write and solve an inequality to find out how long it will take Evan to finish. Okay, well, when we went over the multiplication division problems, some of the rate problems were multiplication, some were division. So how do we know? Well, let's see, it's trying to tell us, it's asking us how long it will take. And I'm guessing, and we talked about how if it asks you for kind of like a bigger number that you're splitting into equal groups, that's going to be a division problem, division inequality. Okay. But if it's not, if they kind of give you, right, this is kind of the large group. If they give you that large group of 120, then that's going to be a multiplication problem, because then we're eventually going to divide. Might not make sense, but let's see if we can make sense of it. Okay, we have the minutes. We know it's $10. Oops, sorry. I like to always do the inequality part first. Right, I have that, and I have a rate, so I know kind of what operations I'm going to be, at least I can get in the ballpark. Okay, so at least 120 is that, greater than or equal to. All right, and what's at least 120? All right, well, how would we calculate the number of problems they can do? Well, they do 10 every minute. So if we were to go and solve that, we divide by 10, divide by 10. Minutes have to be greater than or equal to 120 divided by 10 is 12. And so we're going to interpret that. He's going to spend, Evan will spend at least 12 minutes, or it will take Evan at least 12 minutes to finish the assignment. Okay. All right, let's go on to the next one. Okay, Joey needs at least $20,000 to earn the target Gimkit money for his assignment. He already has $8,500. All right, it says write and solve an inequality to find the amount of money Joey still needs. All right, well, I don't see a rate at all in this. Let's underline what we do have, though. He needs at least 20,000. All right, and he already has earned 8,500. Okay, and what are we trying to find? We're trying to find the amount of money Joey still needs to earn. So we're going to define that variable, amount of money Joey still needs. And we'll call that M. And we'll go find our important vocab. There's no rate actually word, right? There's no like per or anything like that, or each. So it looks like this is just going to be an addition problem. If we take the money he already has earned, which is 8,500. Oops, I forgot to do the at least part. At least, so that's at least 20,000. Okay, and then the money he still needs is just going to be added on to what he already has. And that's all we have to do. All right, so that's just a simple addition problem where we solve by subtracting. All right, and the money he still needs, he has to at least get $1,150 on Gimkit. Okay, so we go back up here. Amount of money Joey still needs. Joey still needs at least $1,150. Okay, two more. We're getting there. All right, we got SpongeBob and Squidward, huh? Both think they sold the most Krabby Patties. The difference in the amount they sold is at most 5. Squidward sold 130, which was lower than what SpongeBob sold. Right in inequality. Let's box it out. Okay, and so write and solve an inequality to determine SpongeBob's possible scores. Okay, so we'll call it SpongeBob's scores or possible score. All right, so let's call that S for score. Okay, make sure you don't confuse it for a 5. All right, and let's go underlining what we have. They both thought they sold the most Krabby Patties. The difference in the amount they sold is at most 5. Squidward sold 130, which was lower. So why does it help to know that that was lower than what SpongeBob sold? Well, because when we find a difference, we want to know which one was higher, which one was lower, and we'll put the higher one first. Just like for finding the difference in our height, you'd take the taller person minus the smaller person. Okay, so let's start with, well, we have to circle some important information. I got at most 5. I got difference, right? That means we're subtracting. Okay, so let's put it into an inequality at most. Okay, so that means less than or equal to 5. And then what is less than or equal to 5? Well, the difference. So we're subtracting. And we should subtract the greater from the smaller. So this is the bigger number minus the smaller number. Okay, and that's why it was important to notice right here that Squidward sold 130, which was lower. So 130 is going to be there, and we'll use S for SpongeBob score. Okay, so there's just a subtraction problem, which we solve through addition. And we have S is less than or equal to 135. So now we have to interpret our solution. So what did the S represent? What did this S represent? It's SpongeBob's possible scores. So SpongeBob could have, I guess, I don't know why it's SpongeBob's possible scores when it's just, it should be SpongeBob, how many Krabby Patties he sold, right? But we can stick with it. So could have sold at, what's the phrase that we used? At most 135 Krabby Patties. All right, and on to the final problem. All right, you should have already read it, so I'm going to go skip down here, and it says write an inequality to find out how many pencils he must find on the floor or in between the couch cushions at home to be able to make his creations. All right. Okay, so already I'm thinking this is one where it's asking us for a total, the big amount, and we're going to split it into equal groups. And let me just read the rest to make sure that that's what we're looking for. So Hudson uses 10 pencils to create each. Okay, so 10 pencils to create each of his amazing creations. So that means we're putting them into groups of 10, right? And how many groups of 10 do we need? He wants to make at least 8 pencil creations. Okay, so see how that is the size of the group and how many groups. And what we're looking for is a, right, how many, right, pencils. That group of pencils is a big group that we're splitting into, a big amount that we're splitting into groups. All right, so let's circle some of our important words. I see the word each, I see at least, so the word each indicates it's either going to be multiplication or division, and I'm trying to indicate that this would be one of the division ones. So let's check it out. At least means greater than or equal to 8. Okay, and then we're going to take, oh, I always do this. I jumped the gun. I did not write down, I did not define my variable. So how many pencils he must find. So number of pencils he must find. So I'm going to do P for pencils, and excuse me. And so let's do that inequality word, at least. So that's greater than or equal to 8. And what is going to make those 8 groups? Well, if we take the whole number of pencils, the total number of pencils, and we're splitting into groups of 10, all right, that's a division idea. Okay, so then when we go to solve it, we'll multiply, and we get the amount of pencils that he needs to find has to be greater than or equal to 80. All right, and then we interpret it with simply restating basically what we defined P as. So the number of pencils he must find, right? So he must find at least 80 pencils to make his beautiful creations. Okay, that's it. Whew. Hopefully you work hard, you prep, and you ask questions, and you learn from your mistakes. Do all that stuff. I'm sure your test day will be the best day. Flex those math muscles on the test. Let's crush it. Good luck.